Okay, so this is going to be like 2.1b. It's the second part of 2.1. We're going to do solve by completing the square. We've done completing the square. The only thing that's slightly different here is that we're not putting in that vertex form. We want to solve for solve for x, even though there's not a y here. So what we're going to do is the first thing we need to do is make sure in this form always has to be equal to 0, which we are, if you see here. The first step is to isolate the x terms. So I'm going to move over the 8 by adding 8 to both sides. I have x squared minus 4x, and over here I have an 8, positive 8. I know that I have to add something here. Okay, something has to go here, something has to go here, whether it's a plus or a minus. Okay, next thing is remember that you had to take b, divide by 2, square it, and then add that to both sides. So that's what this is. First we're going to square b divided by 2. Well, b is negative 4. So we're going to take the negative 4, divide by 2, we get a negative 2. Okay, now we're going to square that, and we get a positive 4. And this is what we add to both sides, 4 and a plus 4. So remember, or realize from before, remember, either way you want to look at it, we were always in something squared equals a number. And we did that, we can take the square root of both sides and solve for x when it's in this form. That's what form, this is the form you want. You want to be in this form somehow when you get done. Then you can do what we did in the last lesson. So now I'm going to write this with, look down here, it's telling you it should be something b squared divided by 2. So I'm going to be something squared equals a number. Well, that number is 12. And then inside here is an x. Remember this inside here, this minus 2 is your nice little hint to put inside there. Now I'm in something squared equals 12. So now I can take the square root of both sides to solve for my x. Here I get x minus 2. Don't forget, it's a plus or minus times the square root of 12. So I need to solve for x. I'm going to go ahead and move this 2 over by adding 2 to both sides. And I wind up with x equals plus or minus the square, oops, I left out the 2. The 2 is going to go in the front. I think I talked about that in the last part. You always want to put the number in front of the radical. Now the only problem is the square root of 12 can be simplified. So what is the square root of 12? The square root of 12 can be, perfect square in there is a 4, so it's 4 times the square root of 3, and then the square root of 4 is 2, so square root of 12 equals 2 times square root of 3. So we want to change our equation to that, and so far final answer will be x equals 2 plus or minus 2 times the square root of 3. Remember, that is 2 solutions. All right, let's look at letter B. Okay, we're going to complete the square. And if we look at letter B, everything's moved to one side. So we're going to move the 13 over by adding 13 to both sides. So we're left with 4x squared plus 24x on the left equals 13. I don't really write it like that yet because I'm not going to do anything. So the next thing I want to look at is I need to factor out an a. That still happens. We want it to be an x inside squared only. So I'm going to take out a 4. My GCF is a 4, so I did factor out a 4. Well, my GCF, I'm sorry, a is what you're factoring out. So you get x squared, 24 divided by 4 is 6. I'm going to rewrite this because it's a common mistake that we're making is that we're not actually, so if I take a 4 out, if you divide everything by a 4, maybe that'll help you to see what's here. This right here that I'm highlighting seems to be a common place where we don't actually divide it out and get that number we need. So that's going to give me a 6x. And I have a space, So I know that I need to add something here and then something here. So b is 6. So now we have b is 6. We're going to take 6 divided by 2, gives me a 3. I'm going to square that, and I'm going to get a 9. I'm going to add 9 here, but on the other on the other side, I need to add the 9 times the 4, and that's going to be a 36. I have to pay attention to what we pulled out. Okay, so on this side, we're going to have a 4. We know it's going to be x, quantity squared. It's going to be a positive 3 equals 36 and 13 is 49. Now I can't take the square root of both sides. Because of this little number here, we have to move it to the other one side by getting rid of it by dividing by a 4. So divide by a 4, divide by a 4. I'm going to give me a space where I'm doing my work. I'll go up here. We're going to have x plus 3 quantity squared equals 49 over 4. Now we can take the square root of both sides. This time we're going to x plus 3 equals the square root of 49. I can write this square root of 49 over 4, square root of 4. You don't have to write like that, but just make sure that you understand that I can do that. But I have a plus or minus 7 over 2. Now, earlier we had a radical. Up above here we had this radical up here. So I can leave it written like this. Well, there's no radical here, so you must give an answer. Now I have two equations. If you want to subtract this negative 3 over here, you can do that. And you'll wind up with x equals negative 3 plus or minus 7 halves. Again, no radical, so I must write my two equations, find those two answers. So my first one is x, negative 3 plus 7 halves. My second one is x equals negative 3 minus 7 halves. So when I do that, I'm going to find a common denominator. So this is actually going to be negative 6 over 2. That one will also be negative 6 over 2. So I get x equals 1/2, and I get x equals negative 13 halves. And those are my two solutions. I do show a lot of work, so sometimes you don't need to show as much work, but so make sure you understand where we're going. All right, this last one for this part. Okay, so now we're going to look at is, again, solving this out by moving the 1 over. So we get negative 3x squared plus 6x equals 1. Factor out the negative 3. We want to factor out this a. So negative 3. So if I divide everything by negative 3, I get x squared minus 2x plus something has to go here equals 1, and then something will be added or subtracted over here. So now we're going to look at b. b is b equals negative 2, divide by a 2. I'm just going to write this. All the other ones I've been writing it to, so where you do. Negative 2 divided by 2 is a negative 1. Square that, you get a 1. So we get a 1 here, but over here we get a negative 3, because 1 times this negative 3. So in the front, we have negative 3. And we know it's going to be x like this. It has to be squared. My hint, what goes inside my parentheses is a negative 1 from this divided by b. And then on this side, we get negative 2. Okay, can't take the square root yet because of that negative 3. So divide both sides by negative 3. You wind up with, and I'll write it over here, x minus 1 quantity squared equals a positive 2/3. So now we can take the square root of both sides. Square root of this, square root of this. I'll write it over here. So I have x minus 1 equals plus or minus the square root of 2 over 3. Move the 1 over. Add that one. X equals 1 plus or minus. Now, the square root of 2/3, I'm going to write it like this because we need to rationalize the denominator. Those are not perfect squares, so I cannot leave a radical on the bottom, so you must do this. So again, rationalize the denominator. We're going to multiply by this here. What's this radical? I'll multiply by square root of 3 times the square root of 3. We want to get rid of that square root of 3. So we wind up with x equals 1 plus or minus. On top we have square root of 6. And on the bottom we have square root of 3 times square root of 3 is the square root of 9, or just a 3. And that's your solution. 2 answers. Okay, next part we're going to do is we're going to review some complex numbers. So remember that we talk about complex as that imaginary number. So we know I equals the square root of negative 1. Okay, so now we're going to just simplify these. We have a negative under the radical. So if we look at letter A, we have the square root of negative 49. So there are different ways you can do this. I just going to break it up. I know the square root of a number, and that negative is underneath here. Square root of 49 is a perfect square, so this is 7. Square root of negative 1 is I. So my answer is just 7i. Now, these are complex numbers where it's a plus bi. Should always be written part. A is real, b and I is imaginary. So what we're going to do with this next one, it's not a perfect square, but find the largest perfect square, like we did earlier. Just want to remind us. Again, if you don't, then you'll have to just, work an extra step, but that's okay. So here I know that 16 times 3 is 48. So I know I have the square root of 16, and I put the square root of negative 1. What I won't take out, I'll put last. That won't come out of the radical, I should say. Square root of 16 is 4. The square root of negative 1 is I. And then we have the square root of 3. So that's your answer. Okay. Next one's slightly different because we have a 6 in the front, but this is multiplication. All right, we found the square root of 12 before. If you look above, we found the square root of 12 to be 2 times the square root of 3, okay? So when we do this, I will still do, I'm going to show you the steps. I'm going to do 4, I'm going to do I, negative 1 for I, and then I'm going to do square root of 3. Because I know those I can take out. So square root of 4 is 2, and it's multiplication. If you want to think it this way, do this. Square root of negative 1 is an I. Square root of 3 stays. It's not a perfect square. And now you distribute. What's 6 times 2? 12. So it's 12i times the square root of 3. Notice just multiplying what's out in the front. Now letter D, okay, is again, this whole thing is all perfect squares. I can write it like that. I can square root of negative 1 there. So take the square root of everything. If you can see that it's going to be a perfect square, you don't have to do these steps. But so I get square root of 16 is 4. Square root of negative 1 is an I. Square root of 25 is 5. You can write it this way, or you can write it with the I next to this. But you cannot write the I in denominator. Those are the only 2 possible solutions. Just want to make sure you see that. You'll see a lot of writing the I's on the side when it comes to fractions. All right, letter E. Again, I'm going to just divide this up. I have a square root of negative 1 times the square root of 2 on the top, and then the square root of 7 on the bottom. Nothing is perfect. Nothing. But I know the square root of negative 1 is I. Okay, so I'll just go ahead and do that now. But I don't want the radical on the bottom, so I have to rationalize it. So I'm going to get rid of the square root of 7 by multiplying by its square root of 7. So on top, you will get I is going to be in front here, okay? I times the square root of 14 over 7 times 7, square root of 49, but the square root of 49 is just 7. Now, you can write it like this. The I is preferable in the front here for mostly probably for making sure that we don't make a mistake. You can do the square root of 14, 7 like this and put I on the outside and make this part of fraction, but it never goes, it's not in denominator either on this one. Okay, let's try F. F is combining a few things. So on F, I have the square root of -1 times the square root of 8 over the square root of 3. Okay, I know that there's a perfect square and the square root of 8, so I'm going to do it over here. Square root of 8 is the same as square root of 4 times the square root of 2. Well, the square root of 4 is 2 times the square root of 2. So I can change that to this. So, but I have a -1, so square root of -1 is I. So it's going to be 2I times the square root of 2. Notice that the I is after the 2, not in front. It's like a variable. That's where it goes. And it's all over the square root of 3. Again, get rid of that 3. You got to rationalize it. So I'm going to multiply the top and the bottom by what I see here inside there is a square root of 3. And I get 2I, well, square root of 2 times square root of 3 is the square root of 6, all over. Again, this is 9. Square root of 3 times square root of 3 is the square root of 9. Well, the square root of 9 is just 3.